In the chaos of World War II, German U-boats were crippling supply lines in the Atlantic, sinking cargo ships at an alarming rate. Until this one changed everything. The Liberty ship, for the most part, was unremarkable. It wasn't fast or slick, but it became one of the most important ships of the Second World War. Built by the thousands, faster than the enemy could sink them, they were a desperate effort to keep the Allies supplied in their war effort against Germany. With an average of 3 ships completed every 2 days from 1941 to 1945, it became the most mass-produced ship in history, helping to turn the tide of the war. In this video, we've modeled the entire ship, inside and out, to break down its design, uncover how it was built, how it worked, and how it helped win the war. By the fall of 1940, Nazi Germany had conquered most of Europe, and Britain stood alone in the fight. Its survival depended on the fragile supply line stretching across thousands of miles of open ocean. In response to this crisis, the United States launched the Emergency Shipbuilding Program. 18 shipyards, thousands of workers, and a single goal: to mass-produce cargo ships at an unprecedented scale, an industrial push unlike anything the world had seen. The design was more than 60 years old, based on a British cargo ship from 1879. It wasn't fast or modern, but it could be built quickly, cheaply, and in massive numbers. At the heart of the Liberty ship was a steam engine, already outdated by the 1940s, but intentionally chosen. More advanced steam turbines required precise manufacturing and materials that were in short supply during wartime. The Liberty ship used technology that was simpler and cheaper, enabling its production by a wider range of companies. Welding replaced traditional riveting. Prefabricated sections were tucked in, dropped into place, and welded together. What once took months could now be completed in a matter of weeks. By September of 1945, 2,710 Liberty ships had been built. They carried military equipment, fuel, and food, delivering vital cargo to battlefronts across the globe. These ships weren't glamorous, but without them, victory might not have been possible. Let's start by going over some of the basics. The front of the ship is called the bow. The back of the ship is called the stern. And instead of using left and right, we use port and starboard. These terms apply to all sailing vessels and are still widely used today, not just for the Liberty ship. And while several variants of the Liberty ship were built, each slightly modified for specific types of cargo, in this video we'll only be focusing on the most common one, the standard cargo version. And by the way, we've turned the Liberty ship into a detailed poster, and we're giving one away. More on that later. With that out of the way, let's look at some of the specs. Liberty ships measured 135 meters in length, with a beam of 17 meters. To put that into perspective, here's a modern cargo ship beside a Liberty ship. The difference is striking, and shows how far cargo ships have come since the Liberty ship was first built, and that's not even the largest in service today. When it came to speed, Liberty ships weren't exactly known for being fast. Their top speed was 11 knots. In contrast, modern cargo vessels, more than twice that size, can reach 22 knots, making them twice as quick. Each Liberty ship carried around 9,000 metric tons of cargo. That may seem modest by today's standards, but it was anything but small. It was the equivalent of more than 250 fully loaded semi-trailer trucks. Crew sizes ranged from 50 to 100 people. Most were civilians from the US Merchant Marine, usually between 30 to 60 crew members. The rest were part of the US Navy Armed Guard, typically 20 to 40 sailors, tasked with defending the ship from enemy attacks during the voyage. Let's look at the key components on the outside of the ship. At the center of the Liberty ship was the main accommodation block. This midship deckhouse spanned multiple levels and held the crew quarters and the bridge. Toward the stern was the aft accommodation. This smaller deckhouse provided additional living space for the crew. Moving on to cargo handling and storage, this area was arguably the most important part of the Liberty ship. Each Liberty ship came equipped with its own derrick cranes, allowing them to load and unload cargo without relying on dockside equipment. The ship's cargo handling system centered around 3 structures topped with tall masts, each supporting a set of booms. These long pivoting arms were hinged at the base and used to move cargo in and out of the ship's holds. Steam-powered winches controlled the lifting cables, running them through pulleys mounted at the ends of the booms. The steam for these winches came from the ship's boilers, which we'll explore later in this video. Covering each of the 5 cargo holds was a multi-layered hatch cover system that needed to be removed for the crew to access the hold. At the outer edge was a raised steel frame called a coaming, which prevented water from washing into the hold. Heavy-duty tarpaulins covered the opening for waterproofing, with wooden boards laid underneath to form a solid floor. Long metal beams, known as strongbacks, were placed across the top to provide support for the wooden boards. Each end of the beams was inserted into metal brackets welded to the coaming. Other exterior features included the radio antennas, mounted on the mast for communication, the funnel which vented exhaust gases from the boilers, and large cowl vents that supplied the ship with air into various places, including the boilers and the engine. On top of the ship sat the flying bridge. This open-air platform gave crew members an unobstructed view of the sea. It was typically used in clear weather or during docking. It also had a duplicate set of navigation and control equipment, just like the enclosed bridge below. We'll go over those controls later in the video. 4 lifeboats were mounted along the sides of the midship house, along with 4 box-shaped metal life rafts. Each was positioned on its own platform. At the bow, you could find the ship's anchors. At the stern, the Liberty ship was fitted with a single 4-bladed propeller, measuring 5.6 meters in diameter, positioned next to the rudder, which was used to steer the ship. During this tumultuous time of war, it's no surprise that the Liberty ships were also armed. At the stern, you typically find a 4-inch 50 caliber gun mounted on a platform above the aft deckhouse. This served as the ship's primary defense against submarines and surface vessels, especially surfaced U-boats trailing from behind. It allowed the ship to fire while retreating. Next to the main gun were 2 3-inch 50 caliber naval guns. These were added to Liberty ships that had been converted into troop transports after 1943 and gave the ship additional protection. To defend against aircraft, the ship carried up to 8 20mm anti-aircraft guns. These were autocannons mounted on raised platforms and spaced out across the ship to cover all angles of approach. At the bow was another 3-inch gun, the same model as the ones found at the stern. To protect the bridge and gun platforms, Liberty ships were outfitted with up to 100mm of plastic armor. This was a composite made from bitumen and aggregate, similar to asphalt. Now let's head inside to see how the Liberty ship was laid out. The ship was divided into 5 main decks, each serving a specific function. We'll begin at the very top of the ship and then work our way down through the ship, deck by deck. Located at the top of the midship structure, the bridge deck housed the ship's central command areas. This is where the crew navigated, steered, and communicated. At the heart of it was the wheelhouse, the main area where the ship was commanded, equipped with all essential navigation and control equipment. At the center of the wheelhouse was the helm, a large wheel used by the helmsman to steer the ship by controlling the rudder. Just beside it was the engine telegraph, a key communication device for sending engine orders to the engine room below. It worked in pairs, 1 unit on the bridge and 1 in the engine room. When the bridge officer moved the handle to the desired order, like full ahead, a bell rang in the engine room, and the pointer on the unit below automatically moved to match the new order. Then the engineer responded by moving the handle to match the command, making the pointer on the bridge move to the new position, ringing a bell in the wheelhouse, confirming the order has been received and acknowledged. Next to the helm was the binnacle, a stand that held the ship's magnetic compass, which used a magnetized card or dial to align with Earth's magnetic field and display the ship's direction relative to the magnetic North Pole. To correct for interference from the ship's steel hull, 2 iron spheres, called quadrantal correctors, were mounted on either side of the binnacle. To protect the crew during attacks, armor plates were mounted above and below the wheelhouse windows and could be flipped down to cover them. Beside the wheelhouse was the chart room, where the ship's maps were stored and plotted. It also housed the gyro compass, a device that used a fast-spinning gyroscope to maintain orientation toward the true North Pole. Unlike a magnetic compass, it wasn't affected by magnetic fields. The magnetic North Pole shifts over time due to changes in Earth's magnetic field and does not align with the true North Pole. The angle between them at a given location is called magnetic variation. Opposite the chart room was the radio room, which held the ship's communication equipment. Next to it was the battery room, used for backup power. The bridge deck also included private quarters for the captain, featuring a sleeping area, an office, and a private shower, wash basin, and toilet, or head as they were called on ships. 2 additional officers' cabins were located nearby, each furnished with a bed, desk, storage, and wash basin. At the center of the deck was the boiler casing, a protective enclosure around the boiler uptake, which vented hot exhaust gases from the boilers up through the funnel. Directly below the bridge deck was the boat deck. This entire deck was dedicated to the remaining officers' quarters. Each room included private sleeping and living areas, with access to nearby showers and toilets. Next up is the upper deck. In the midship section, you'd find the galley, where all meals were prepared. Then, there was the crew mess, where the crew dined and socialized. Located near the crew mess, officers had their own separate mess, called the officers' mess. This deck also held additional crew quarters, which included toilets and showers. Toward the stern, directly beneath the gun platform, were the armed guard quarters, home to the military personnel responsible for defending the ship. This section also housed a small hospital, used to treat injured crew members. Let's move on to the second deck. This level includes the tween decks, the upper cargo spaces for the main cargo holds 1 through 5. These areas allowed for flexible storage by creating separate compartments within each hold. Wooden boards placed on strong backs covered the lower cargo hatches, forming a solid surface for stacking additional cargo. When needed, these covers could be removed to access the hold below. In Liberty ships converted to troop transports, these twin decks were repurposed as berthing and mess areas, with enough space to carry around 500 soldiers. In hold number 4, there were small hatches for accessing the dry ballast tank. At the bow, you'd find the bosun's stores, a supply room for maintenance equipment. Next was the carpenter's shop, a small workplace where the ship's carpenter could carry out repairs, and the forward magazine, a secure room used to store ammunition. Below was more storage. And finally, tucked beneath the carpenter's shop was the chain locker, where the ship's heavy anchor chain was stowed. In the midship section of the second deck, an opening in the floor provided a view into the engine and machinery spaces below. Surrounding this were several storage rooms, including rooms housing a freezer and refrigerators to properly store perishable food supplies. Finally, at the stern, the steering gear room housed the powerful mechanism that turned the rudder to steer the ship. It all began with a steam-powered steering engine, which converted steam pressure into rotary motion. That motion drove a worm gear, a screw-shaped gear that turned a worm wheel, a large horizontal gear it meshed with. Because of the worm gear's design, the worm wheel couldn't spin the worm gear in reverse. This self-locking feature was important as it prevented back driving from rudder forces. The worm wheel then drove the pinion gear, which engaged with the teeth of a curved quadrant. This setup provided a second stage of torque multiplication, giving the steam engine enough power to turn the rudder. The quadrant was loosely fitted to the rudder stock. It didn't move the rudder directly. Instead, it was connected by heavy springs to a large forged arm called the tiller. These springs absorb shock loads from rough seas and help protect the rest of the steering system from damage. The tiller was firmly attached to the rudder stock, a vertical shaft that ran down to the rudder blade below. As the tiller moved, it rotated the rudder stock, which in turn pivoted the rudder blade, steering the ship through the water. Also located on the stern section of the second deck was the aft magazine. This area was used to store ammunition. Next, at the very bottom of the ship was the tank top, the lowest accessible deck. It formed a physical top of the double bottom, which held fuel oil and provided ballast to stabilize the ship. This structure also added a layer of protection in case the hull was breached. The tank top also served as the lower cargo level for all 5 holds, where heavier items were typically stored. In cargo hold number 1, there were 4 hatches leading to deep tanks 1 and 2, which could be used for cargo or ballast. Hold number 4 had 2 hatches leading to deep tank 3, serving the same purpose. Located midship of the tank top, the engine room housed the heart of the Liberty ship, a towering vertical triple expansion steam engine. It measured 6.4 meters long and 5.8 meters tall and generated 1900 kilowatts of power. We've added a human figure next to it to show just how massive it really was. The engine ran on a closed-loop steam cycle. Here's how it worked. Water was heated in 2 oil-fired water tube boilers located just ahead of the engine. Pressurized heated fuel oil was pumped through fuel lines to 4 burners on each boiler. At the tip of each burner, the oil was atomized into fine mist to allow better combustion. At the same time, a large blower drew in air from outside the ship and pushed it through a duct beneath the floor, forcing it upward into the base of each boiler. This forced air mixed with the atomized fuel, and the resulting mixture was ignited in the firebox, producing an intense flame. The firebox itself was lined with heat-resistant fire bricks to withstand the high temperatures. As combustion gases moved through a controlled path inside the boiler, guided by internal baffles, they traveled upward and out through the uptake, eventually being released through the funnel. Feed water was pumped into the boiler by a feed pump and entered through the steam drum at the top of the boiler. From there, it flowed down into the front header, which distributed it into a series of generating tubes. As the water moved through these tubes, it absorbed heat from the combustion gases and began to turn into steam. The resulting steam-water mixture flowed into the rear header, then back into the steam drum, where steam was separated from the remaining water. Saturated steam exited from the top of the steam drum and passed into a set of superheater tubes, positioned directly in the path of the hot exhaust gases. There, the steam was heated even further, becoming superheated steam, which contained more thermal energy. This high-energy steam was then directed to the main engine, as well as to smaller steam engines that powered auxiliary systems, such as generators, pumps, boiler blowers, the steering engine, and cargo winches. The engine itself had 3 vertical cylinders of increasing size arranged in a line. Each piston was connected to a rod, which was guided by a sliding block guide called a crosshead. The crosshead transferred motion to a connecting rod, which in turn rotated the crankshaft, converting the up and down movement of the pistons into rotary motion. Looking inside the engine now, this engine was designed to progressively lower steam pressure in each of its 3 cylinders to extract further energy. Each cylinder had its own valve that controlled the flow of steam in and out by moving up and down. These valves were operated by rods driven by eccentrics, or circular discs, mounted off-center on the crankshaft. High-pressure steam from the boiler first enters the steam chest of the smallest high-pressure cylinder. When the valve is in its lowest position, steam flows into the cylinder and pushes the piston downward. As the piston moves, the valve begins to rise, cutting off the flow of additional steam. The steam already inside continues to expand, driving the piston to the end of its stroke. At the end of the stroke, the valve reaches its highest position, allowing the now lower pressure steam to exit the high pressure cylinder and flow into the steam chest of the intermediate pressure cylinder. There, the cycle repeats. Steam pushes the intermediate pressure piston, expands, and then exits. Finally, the exhaust from the intermediate pressure cylinder enters the largest low pressure cylinder, where the same cycle occurs once more before the steam is exhausted into the condenser. Running through cargo holds 4 and 5, a long steel tunnel called the shaft alley connected the crankshaft to the ship's propeller and was supported along its length by large bearings. This tunnel, which was large enough for personnel to enter for maintenance work, ran all the way from the engine room to the stern. Once the steam had done its job, it passed into the main condenser. There, cold seawater flowed through a series of tubes. When the hot steam touched these cooler surfaces, it condensed back into water. That water was then pumped back to the boiler, ready to begin the cycle again. This closed-loop system powered nearly every function of the Liberty ship. An auxiliary condenser handled the same process for the smaller steam-powered engines throughout the ship, including the ship's steering engine and the cargo winches. This completes the steam-water cycle, which would repeat continuously throughout the voyage. The Liberty ship's standardized, prefabricated design allowed for record-breaking production speeds, an innovation that not only met the demands of World War II, but also reshaped global manufacturing and supply chain practices for years to come. But as the war progressed, the ship's limitations, especially its modest speed, became clear. To address this, the US introduced the Victory ship, a faster, more powerful successor with similar cargo capacity. These new ships carried the momentum of Allied logistics through the final years of the war. Between 1944 and 1946, 531 Victory ships were built. Today, only 4 Liberty ships are left, and just 2 still operational. The SS Jeremiah O'Brien in San Francisco and the SS John W. Brown in Baltimore. That's exactly why we created this Liberty ship poster, to preserve a piece of that legacy in visual form. And we're giving one away. To enter the giveaway, like the video, subscribe, and comment below. What's the most interesting thing you learned about the Liberty ship in this video? We'll announce the winner in the next upload, or grab one for yourself. But it's only available for a limited time. Link is in the description. Before we go, we want to announce the winner of our last giveaway. Congratulations, and thank you for your comment. A huge thank you as well to all of our Patreon and YouTube membership supporters. Your support truly makes videos like this possible. Thank you for watching. Stay curious.